Good day everyone, it's Manuel from grade 10 St. Jude, and today we're going to tackle about the topic geometric sequence in mathematics. Let's have a recap. We already know from our previous topics that a sequence is an ordered list of numbers. Example 1, 2, 3, 4, and so forth. Another one that we already know is the nth term. The nth term is a formula that enables us to find any term in a sequence. We use the nth term as a formula to get the term we want to know. A sequence can either be an arithmetic or geometric, and today we're going to tackle the geometric sequence. Remember that a sequence is geometric if there is a common ratio, which is represented by the number r. A common ratio can be determined by dividing any term in the sequence by the term that precedes it. Unlike in arithmetic sequence, we minus the term and the term before it, while in geometric, we divide the term and the term that precedes it. Remember that it is only a common ratio if the consistency between all the terms is the same ratio. Let's get to the part 1 of our lesson, which we will know the formula and how to determine if it is a geometric sequence or not. Again, the nth term is the formula that enables us to find any term within the sequence. And the nth term of a geometric sequence is a of n is equals to a of 1 multiplied by ratio raised to n minus 1. Remember that a of 1 is our first term, and r is not equals to 0. Again, number r is the common ratio. Let's use everything we learned in a problem. Is this expression a geometric sequence? The first given sequence is 1, 2, 4, and 8. And how can we determine again if it is a geometric sequence or not? If they have a common ratio. And to determine its common ratio, we divide any term by the term that precedes it. So in here, we get 8, which is a of 4. And the term that precedes it is a of 3, which is 4. And so we divide 8 divided by 4 is equals to 2. Is the ratio consistent between all the terms? Let's get another one. Let's use a of 3 divided by a of 2. So the a of 3 is 4 and a of 2 is 2. If we divide those, we get the number 2. So that's our ratio. And as what you can see, they are the same and consistent between the terms. So the first given sequence is a geometric sequence. The answer is yes. The second given sequence is 2, 4, 6, and 8. Let's express if it is a geometric or not. So again, we use the term 8 and the term that precedes it, which is 6. We divide those and we get 4/3. Using another one, we divide 6 and the term that precedes it, which is 4, and we get 3/2. As we can see, we don't have any common ratio. So the second expression is not a geometric sequence. The answer is no. Third given is 10, 9, 8, 7, and so forth. Let's express if it is a geometric sequence or not. We use the term a of 3 and divide it by the term that precedes it, which is a of 2. And this is 8 divided by 9 is equals to 0.89. And to check this, we use another one in order to determine if they have a common ratio or not. So we use a of 2 divided by a of 1, which is 9 divided by 10 is equals to 0.9. So this expression is not a geometric sequence. The answer is no. The fourth given sequence is 4, 16, 64, and 256. Let's determine if it is a geometric sequence or not. So we divide a term by the term that precedes it, which is a of 4 divided by a of 3. 256 divided by 64 is equals to 4. That's the ratio of 64 and 256. But is it the same throughout the sequence? Let's get another one. So we divide a of 2 by the term that precedes it, which is a of 1. So 16 divided by 4 is equals to 4. As what we can see, they have a common ratio. So the fourth given expression is a geometric sequence. The answer is yes. Now let's go to part 2, where we will focus on solving and finding the missing term. In question number 1, we are given a sequence of 2, 6, 18, 54, and question mark. We can see that the number 2 is our first term as indicated. 6 is our second term, 18 is our third term, 54 is our fourth term, and our fifth term is missing. The missing term is what we are going to find. Since it is the fifth term, it is gonna be n is equals to 5. We already discussed the nth term, or the formula that enables us to find any term within the sequence. And the nth term of a geometric sequence is a of n is equals to a of 1 multiplied by ratio raised to n minus 1. So in first, we will going to find what's the a of 1. And our first term is 2. So that's our a of 1. Next one is, we're going to find its ratio. And to determine the common ratio, again, we choose any term and the term that precedes it, and we're going to divide it. So, as stated in our PowerPoint, we chose number 6 divided by 2 is equals to 3. Now we have our a's of 1 and common ratio. Let's plot it in our nth term. So, a's of 5, it's 5 because the missing term is the fifth term. That's why we are going to substitute the n in a's of n. It's going to turn it into 5. And our a's of 1 is 2. So, a's of 5 is equals to 2. Our common ratio is 3. And then it's raised to, again, the missing term, which is the fifth term. So, it is raised to 5 minus 1. And so, the nth term for the question number 1 is a's of 5 is equals to 2 multiplied by 3 raised to 5 minus 1. Solve it, and we have a's of 5 is equals to 2 times 3 raised to 4. And then, we're going to solve the exponent, which is 3 raised to 4 is equals to 81. Multiply that by 2, and we have 162. So our a's of 5 is equals to 162. Our missing term, which is the fifth term, is equals to 162. Second given sequence is 3, 15, question mark, 375, and then 175. Our missing term is the third term. Same concept as what we've solved earlier. Since our missing term is our third term, then our n is 3. Let's determine our a's of 1, and our first term is 3, so our a's of 1 is 3. Let's find its common ratio. 15 divided by its preceding term 3 is equals to 5. And then our nth term in geometric sequence is a's of n is equals to a's of 1 multiplied by the common ratio raised to n minus 1. Plot in our given, it's gonna be a's of 3 is equals to 3 multiplied by 5 raised to 3 minus 1. Simplify our exponent first because of the PEMDAS. So it's gonna be a's of 3 equals to 3 multiplied by 5 raised to 2. And then solve the problem. A's of 3 is equals to 3. Since it is 5 squared, it's gonna be 25. So 3 multiplied by 25, it's gonna be 75. A's of 3 is equals to 75. Our missing third term is equals to 75. Into the final part, which is part 3 of our lesson, is find and solve the integrated problem. In this problem, we are going to find the ninth term. So our given sequence is 4, negative 8, 16, negative 32, and so on. Since, again, we're going to find the ninth term, our n is equals to 9. Let's determine our a's of 1. Our a's of 1 is 4 because that's our first term. Finding our common ratio, let's use 16, and then its preceding term is negative 8. Divide that, and we have negative 2. Plot in our given in the nth term of the geometric sequence. A's of n is equals to a's of 1 multiplied by common ratio raised to n minus 1. So it's gonna be a's of 9 is equals to 4 multiplied by negative 2, 9 minus 1. Simplify our exponent. It's gonna be a's of 9 is equals to 4 multiplied by negative 2 raised to 8. Solve the problem is a's of 9 is equals to 4. Since it is negative 2 raised to 8, since it is an even number, it's gonna be positive, and it's equals to 256. Multiply 256 to 4, and we have a's of 9 is equals to 1024. Our final answer is the ninth term is equals to 1024. Our second problem is finding the seventh term. Our given sequence is negative 1, negative 5, negative 25, and negative 125, so on. So, we're going to find the seventh term, so it's going to be n is equals to 7. let's determine ace of 1 and its common ratio. Our first term is negative 1, so that's our ace of 1. And then in common ratio, we're going to use negative 125, and let's divide it by its preceding term, which is negative 25. Negative 125 divided by negative 25 is equals to positive 5. The nth term in geometric sequence is ace of n is equals to ace of 1 multiplied by common ratio raised to n minus 1. Plot in our givens is going to be ace of 7 is equals to negative 1 multiplied by 5 raised to 7 minus 1. Simplify our exponent. 7 minus 1 is 6. Ace of 7 is equals to negative 1 times 5 raised to 6. Solve the problem. Ace of 7 is equals to negative 1. Since 5 raised to 6, it's gonna be equal to 15,625. Multiply now 15,625 to negative 1 is equals to our final answer, which is ace of 7 is equals to negative 15,625. This is our final answer. Our seventh term is negative 15,625. That's the end of our topic. Thank you for tuning in our lesson on geometric sequence. See you again!